I'm sorry, I ran out of memory there in the middle of problem 4, so I'm starting over. I'm not sure how much showed up before, so you can zoom ahead if this is repeated. All right, the arc cosine of the cosine of 4 pi over 3. I'm wondering if the arc cosine just undoes the cosine, and the answer is 4 pi over 3. But I gave you that warning on the last one. It doesn't always work like that. And this one is different also in that inside is not an inverse trig function, it's a regular trig function, and the inverse trig function is on the outside. But we'll just follow our mathematical nose and it'll lead us where we have to go. So this asks me to find the cosine of 4 pi over 3. So I don't have my unit circle, you can just look at yours. So 8/3 is the same as, 4/3 is the same as 8/6. So I'm going to count 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6. So I found 4/3 pi by changing it to 6, then counting around the unit circle. That looks like it's over short, down long, -1/2, negative square root of 3 over 2. So cosine is the first coordinate. So this is asking me, this whole inner quart here became -1/2. It's asking me to find the arc cosine of -1/2. So this is on your unit circle, and you're looking for a angle in the first or second quadrants. And I gave you the tip today, if it's negative, it's going to be in the second. Where is there a coordinate in first coordinate in the second quadrant that's -1/2? And I investigated that and found it to be somewhere. Where did I find it? I think I found it right here, because the coordinates there is back a short, up a long. So the first coordinate is 1/2. So what is that? 1, 6, 2, 6, 3, 6, 4, 6 reduced 2 pi over 3. So the answer is 2 pi over 3. And notice the original problem had a 4 pi over 3 in it. So why wasn't the answer 4 pi over 3? Because we can only look for our cosine in the first and second quadrant. So that's why these aren't matching like they did in the last problem. So 2 pi over 3 is the answer to that one. All right, now I want to do number 5, and number 5 is more like what your homework is going to be. I have 5 problems for you to do. And so we can zero in on this closely. Sine of the arc cosine of 3x. So I think I introduced a variable inside this argument here, so we're going to get comfortable with that. So first of all, we go into the inner quart, and we are looking for a angle that has a cosine of 3x. We are only allowed to look in the first and second quadrants. It's positive. We'll look in the first. So I'm going to draw a first quadrant triangle, and this is, I'm going to make a fraction out of it. So this is side adjacent to the angle, and this is side hypotenuse. And so I've set it up. If I Pythagorize that, my word, 3x squared plus the side I'm looking for squared equals 1 squared. Notice these are a little harder to use the Pythagorean theorem on, but not impossible. So I'm going to square that and move it to the other side, s, and take the square root. Square root of 1 minus 9x squared. All that under the radical, the square root. So that is my s. So allow me to erase that work so it's not so cluttered. And put an answer in right here. Square root of 1 minus 9x squared is that side. So You can see that that one doesn't come out real nice and neat, but that's not the end of the world. We're okay with that. Now we find the sine of that triangle, and it turns out the sine is side opposite over hypotenuse. So in this case, it's square root of 1 minus 9x squared over 1, but I'll just drop the 1. So the final answer, and your answers in your assignment will look more like that. All right. And I killed the phone. Where'd it go? Could someone kill the phone, please? All right. I'm going to shine the camera onto your assignment. And I'd like you to, it's just like these 5 that we did, most like number 5. So you're all prepared to do that. Here's the assignment right here. Get it good in this camera there. See those 5? All right, take a moment, jot those down, and give it your best efforts. And I expect those, along with, there's some odd problems on the yellow sheet, and we're up to 8 problems on our trig project, and these 5. So that'll keep you busy and hopefully enjoying life. So I'll see you in class. Bye.